Water is everywhere, but clean water isn't. 71% of the Earth's surface is covered by water. However, only 2.5% of it is fresh water, and 70% of the fresh water is difficult to be exploited for human use because it is either frozen in the ice sheets in Antarctica and Greenland or stored deep under the soil. The total amount of fresh water that can be used by human beings only accounts for 3 out of 100,000 of the total amount of water on the Earth. The clean water we can obtain from the fresh water is even less. We use water every day, and the most crucial use of clean water is for drinking. However, according to UNICEF, globally 663 million people live without easy access to clean water, and 2.4 billion people lack access to improved sanitation facilities. The water they get is often contaminated. In developing countries, as much as 80% of illnesses are linked to poor water and sanitation conditions. Countries like Libya, Western Sahara, Yemen, Djibouti, and Jordan, and so on, suffer a lot from the lack of access to clean water. In sub-Saharan Africa alone, approximately 102 million people, that's more than half of the country's population, drink water that comes from dangerous resources like surface water. In this video, we will be focusing on constructing safe water systems. This requires collaboration between civil engineers, chemical engineers, mechanical engineers, and environmental scientists. They will talk about how they will utilize their expertise when working with each other, and also discuss how they will comply with the professional values and fulfill their obligations to the three main stakeholders: the public, themselves and their profession, and their employer or client.
When it comes to providing access to clean water to the population, it is my role as an environmental scientist to protect both the health of the environment and the population. I collect and analyze environmental data such as water samples and identify contaminant sources that could have a negative impact on consumers. Once the data has been thoroughly analyzed in the lab, I compile the data and communicate them in form of a report. It is also my responsibility to convey these results to important stakeholders such as the population, as well as scientists and engineers. We're present throughout the construction of infrastructure involving water, constantly collecting samples and making sure that the quality is up par. For example, if the engineers are using processes or materials that leave drinking water contaminated, it is the role of the environmental scientists to inform them so that adequate modifications can be made to prevent further harm. We also inform the engineer when soil and other surroundings in the environment are being harmed, since it's also our job to protect the environment.
Mechanical engineers are also a crucial part of the team, as they would be the members knowledgeable for maintaining the systems in the water treatment plant. We work on a variety of scales, designing small package plants as well as large municipal and industrial treatment facilities, pumping stations, reservoirs, distribution systems, and sewers. During the new placement of a plant, a mechanical engineer would be responsible for the planning and designing of the components while selecting the most cost-effective solution. It's also their responsibility to select competent consulting engineers for advice on the various subsystems. They are also in charge of quantifying and managing the risks concerning the machineries.
As a chemical engineer, I can provide a lot of expertise in the purification processes of water. My role is to take purification processes in the lab and optimize it to large-scale applications. I have to take into consideration how I can maximize the production of the pure water, maximize the quality of the pure water, and minimize the cost. Desalination is one of these processes, where salt is extracted from seawater to produce water viable for safe use. Desalination tends to require a lot of energy. Chemical engineers like I research alternate solutions such as nanoosmosis and the use of solar energy to be more cost efficient and energy efficient. Distillation is another process widely used to purify water. Chemical engineers must consistently improve distillation processes in the production of small decentralized units that work well in places with severe distribution problems. I'm actively working on creating inexpensive distillation units that can remove contaminants from any water source in order to increase the water accessibility in developing countries.